US Physics Olympiad, year 2021. F equal MA, first round. As usual, it was given 75 minutes for 25 problems. If you want to get more interesting problems, just subscribe for this channel. The following information applies to problems 1 and 2. At the time t equals 0, a small ball is released on the track shown with an initial rightward velocity. Assume the ball always rolls along the track without slipping. First problem. The ball starts at point A, turns around at point B, and returns to point A. Which of the following shows the speed of the ball as a function of time? Problem number 2. Which of the following shows the horizontal velocity of the ball as a function of time? Problem number 3. Two massless rods are attached to frictionless pivots with their ends touching. The distances between the pivot points and the endpoints of the rods are shown below. Neglecting friction between the rods, if a force big F is applied at the left end of the left rod, what force F prime must be applied at the right end of the right rod to keep the system in equilibrium? Problem number 4. Alice and Bethany stand side by side on the Earth's equator. If Alice jumps directly upward in her frame of reference to a small height h, much less than the radius of the Earth, she will land a distance big D to the west of Bethany. If Alice had instead jumped to a height 2h, how far to the west of Bethany would she land? Neglect air resistance. Problem number 5. A train starts from city A and stops in city B. The distance between the cities is s. The train's maximal acceleration is a1 and its maximum deceleration is a2 in absolute value. What is the shortest time in which the train can travel between A and B? Problem number 6. A cylindrical bucket of a neglectable mass and radius r and height h and is open at the top. It is submerged in water of density ρ, with its top distance h big below the surface. How much work is needed to pull the basket slowly so that its bottom is just above the lake surface? Problem number 7. A point mass slides with the speed v on a frictionless horizontal surface between two fixed parallel walls, initially a distance big L apart. It bounces between the walls perfectly elastically. You move one of the walls toward the other by a distance 0.01 big L with a speed 0.0001 v. What is the final speed of the point mass? Problem number 8. A mint produces 100,000 coins. Upon weighting some of them with a precise scale, officials find that the coins vary slightly in weight with an independent uncertainty of 1%. About how many coins must be randomly sampled and weighted in order to determine the total weight of the coins with the 0.1% uncertainty? Assume there are no sources of systematic uncertainty. Problem number 9. NASA trains astronauts to experience weightlessness with an airplane which flies at a parabolic arc with a constant acceleration g downward the ground. The plane can remain on this trajectory for at most 25 seconds due to the large change in altitude required. If instead of simulating weightlessness, NASA wanted to fly a trajectory that would simulate the gravitational acceleration of Mars, 3.7 meters per second square. For what length of the time can the plane simulate Mars gravity? Assume that the maximum change in altitude is the same for both trajectories. Problem number 10. A uniform solid circular disk of mass m is on a flat, frictionless horizontal table. The center of mass of the disk is at rest and the disk is spinning with angular frequency omega 0. A stone modeled as a point object also of mass m is placed on the edge of the disk with zero initial velocity relative to the table. A rim built into the disk constrains the stone to slide with a friction along the disk's edge. After the stone stops sliding with respect to the disk, what is the angular frequency of rotation of the disk and the stone together? Problem number 11. Projectiles A, B, and C are simultaneously thrown off a cliff and take the trajectories shown. Neglecting air resistance, rank the times TE, TB, and TC they take to hit the ground. Problem number 12. An object of mass small m equal 1 kg is attached to a platform of mass big M 4 kg with a spring of spring constant K equal 400 newtons per meter. There is no friction between the object and the platform, and the coefficient of static friction between the platform and the ground is mu equal 0.1. The object is placed at its equilibrium position and then given an horizontal velocity v. For what v will the platform never slip on the ground? Problem number 13. A car is driving on a semicircular racetrack. Its velocity at several points along the track is shown below. Which of the following could depict its acceleration at the corresponding points? Problem number 14. A bacterium cell swims by rotating its bundle of flagella to counter a viscous drag force in the medium. The drag force F as a function of R, V, and nu only depends on the typical length scale of the cell R, its speed V, and the viscosity of the fluid nu, which has units of kilogram over meters by seconds. It is observed under a microscope that a cell of length 1 micron swims at about 20 microns per second. Estimate the speed of a cell of length 0.5 microns, assuming cells of all sizes generate the same amount of force from their flagella. Problem number 15. A block is released from rest at the top of a fixed frictionless ramp with horizontal length L and the inclination theta. For a fixed value of L, which value of theta minimizes the time needed for the block to reach the bottom of the ramp? Problem number 16. A particle begins at the point x equals 0 and moves along the x-axis with initial rightward velocity v0. Later the particle reaches the point x equal L. The velocity as a function of position during this time interval is shown below. Consider the following three statements. First, the particle instantaneously stops at x equal L. Second, the particle is uniformly accelerated. Third, the particle could be performing simple harmonic motion. Which of these statements are true? Problem number 17. In a certain country, the short hand of a clock is exactly half as long as the long hand and rotates twice for each rotation of the long hand. The 3 points shown on the clock hands have acceleration of magnitude AA, AB and AC. The point B is at the midpoint of the long hand. Which of the following is true? Problem number 18. A factory's smokestack continuously produces smoke. The smoke always rises with a constant speed relative to the air around it. Suppose that the air was initially still, then abruptly started blowing to the right, then abruptly became still again for some time. Which of the following could show the resulting shape of the smoke plume? Problem number 19. A cavity of radius r over 2 is dug out of a spherical planet with a uniform mass density of mass m and radius r. What is the magnitude of the gravitational field at point P in the diagram below? Problem number 20. The line between day and night on a planet or moon is called the terminator. How fast does the terminator of Earth's moon move across its surface at the equator? The radius of the moon is 1.74 multiplied by 10 power 6 meters. Problem number 21. A solid sphere sits at the top of a ramp of a height h inclined at angle theta to the horizontal. Both the static and the kinetic coefficients of friction between the sphere and the incline are mu k equal mu s equal 0.2. The sphere is released from rest at the top of the incline. For which of the following values of theta is the total translational plus rotational kinetic energy of the sphere greatest when it reaches the bottom of the incline? Problem number 22. A ship rams into a hunk of ice floating in the sea. Icebreakers are ships designed so that when this happens, the ice is pushed down beneath the ship. If the coefficient of static and kinematic friction between the ice and the ship is mu, what condition applies to the angle theta as shown in the figure, so that the icebreaker functions as intended? Problem number 23. An imperfect spring has a restoring force F that depends on the displacement x from equilibrium as in the graph shown below. The slope of the curve for x less than negative d and x greater than d is a constant k. A mass m is attached to the spring and released from rest at the position x equal a, where a greater than d. What is the period of the subsequent motion? Problem number 24. Two satellites are in circular orbits around a star with equal radius r, speed v and the period t. The satellites are initially diametrically opposite each other. In order to meet the second satellite in time t/2, the first satellite should decrease its speed to approximately next one. Problem number 25. Spaceman Fred's trusty pellet sprayer is held at rest a distance h away from the center of a planet orb, which has radius big R much less than h. The pellet sprayer ejects the pellets radially outward, uniformly in the plane of the page. These pellets are all launched with the same speed v, so that a pellet launched directly away from orbit by the pellet sprayer can just barely escape it. What fraction of the pellets eventually lands on orb? Hint: you may use the small angle approximation sin theta approximately equal theta for theta much less than 1, where theta is in radians. On left picture we have the pellet sprayer relative to orb, and on the right picture we have a close-up of the pellet sprayer.